A tennis player on serve tosses a ball straight up. While the ball is in the free fall, does it accelerate? Does it acceleration A increase, B decrease, C increase and then decrease, D decrease and then increase, E remain constant?
Okay, so uh, if it is free fall, the acceleration is always constant, and that acceleration, whether you are up or you are moving up or you are moving down, it doesn't matter. The acceleration is always constant. And how much is it? Negative 9.8. Negative 9.8. So the first thing that you need to know and remember is the acceleration due to gravity is always the same and is always negative. The second part, you read the second question.
As the tennis ball of Quick Quiz 2.6
Travels through.
travels through the air, does its speed increase, decrease, decrease and then increase and then decrease, or remain?
So if you hit the ball, the ball goes up and come down. On the upward journey, what happened to the velocity on the upward journey? Become faster and faster or slower and slower as you go up this way. You throw something up. What happened to the velocity? Faster and faster or slower and slower as you go up?
Going up is
Okay,
slower and
slower, right?
slower,
Slower. Then when you come down,
fast.
faster and faster. So the velocity will decrease, then increase, or increase, then decrease. Which one? What happened to the velocity?
De- decrease then increase.
Correct. So because go up, decrease lah, come down, increase. So the answer is decrease, then increase, right? So this is correct. Okay. Now, you read this one first. 2.8, a skydiver.
A skydiver jumps out of a hovering helicopter. A few seconds later, another skydiver jumps out, so they both fall along the same vertical line relative to the helicopter. Assume both skydivers fall with the same acceleration. Does the vertical distance between them increase, decrease, or stay the same? Does the difference in their velocity increase, decrease, or stay the same?
There are three questions here. Okay, there are three questions here. Let's see, huh? Okay, three questions here. What are the three questions? Oh, yeah.
Two questions. There's two questions.
Okay,
This is, does the vertical distance between them increase, decrease, or stays the same?
Oh, okay. Right. So two questions. So they both fall along the same vertical line relative to the helicopter. Assume both skydivers fall with the same acceleration. Thus, the vertical distance between them increase, decrease, or stay the same. Okay, so we have one person jump out of the helicopter. Jump out of the helicopter. So after some time, this person will be somewhere at the bottom of the helicopter, right? At the bottom here. Then a second person jump out of the helicopter. So both of them, they are moving downwards. So there is a difference in the distance between them. So the first question is the difference in the distance between them. Will they move further and further apart, that means the one behind cannot catch up with the first one. Okay, will they move further and further apart, or they are closer and closer apart because the second one is going to catch up with the first one? Okay, so that is the first question, the difference in the distance between them. Then the second question is, hey, this person is moving with a certain velocity. This person is moving with a certain velocity. Of course, because this person at the bottom there, he jumps out the first, so he then this person second. So of course, the first person will have a higher velocity lah, right? This one follow behind, he will be slower lah. It will take quite some time for him to attain the same velocity. But because this person started first, so he's always lagging behind. So the second question want to know the difference in velocity between the first person and the second person. The difference in velocity, not the actual velocity. The actual velocity, the first person definitely will be faster than the second one. But the difference in their velocity, will this difference become bigger and bigger, or the difference between them is always the same? Let's say this person is 10 meter per second, right? 10 meter per second. This person is traveling at 20 because he jumped first lah, he will be moving faster. So the difference in velocity is how much? 10 meter per second. So as this person attain a velocity of 20, let's say this person attain a velocity of 20, how much is this person? Okay, if this person attain 30, right? The difference between them is still 10. The difference between them is 10. So in the next second, this person 20, this person 30. The difference between them is also 10. So the difference between them is constant. Now, if let's say this person is 20, this person is now 50, right? So at first the difference between them is 10. Oh, now the difference between them is 30. So the difference in speed or velocity is not the same. It is changing all the time, right? So which is the case? The difference in velocity will stay constant, or the difference in velocity will become bigger and bigger, or the difference in velocity will become smaller and smaller. So that is the second question. The difference in the velocity. The difference in the velocity, will it increase, decrease, or stay the same? Well, this is very difficult to answer because we have no experience jumping out of the helicopter. So it's very difficult to answer. So we don't know, right? Don't know. The same thing with the vertical distance. Is the vertical distance between them going to increase, decrease, or is it going to be the same? Well, very difficult to imagine, right? Quite difficult. But do you understand the question or not? You understand the question? Okay, so if you understand the question, then I can show it mathematically. I can show it mathematically. Okay, right. So how to show it mathematically? I try. This one is the vertical distance between them. So I want to find how far they have traveled. So I use this formula. S equals to ut plus half at squared. Okay, I use this formula. S equals to ut plus half at squared. Okay, now let me adjust this thing. Cannot one, or why like that? Or maybe I put here. Yes, okay. Now when they jump out of the helicopter, the initial velocity, u, you call it u, or you call it the v naught, we call it U or V naught, is actually 0. When you jump out of the, the initial velocity is actually 0. This one is actually 0. So when this is 0, you are left with half at square, half at square, because the initial velocity is 0. So this person, A is the first person. The distance from the helicopter is half at square, because the initial velocity is 0. So after 5 seconds, did they say after five, let's say 5 seconds, they say after a few seconds. So I assume that it is after 5 seconds, the second man jump out of the helicopter. Okay, the second man jump out of the helicopter, and his position from the helicopter will be using the same formula, ut plus half at square, but the initial velocity is 0. You are left with only half at square, half at square. But the t is 5 seconds later. Okay, 5 seconds later. So this will be the distance for the second person after a certain period of time. Okay, so I find the distance or the displacement of the first person and the displacement of the second person. This is the displacement of the first person. This is the displacement of the second person. I use the what? Equation of motion, this one. Ut, not U. You use the formula. You use this symbol. V naught. V naught. V naught. Okay, this is V naught. Okay, so this is the formula that we're going to use. Because the initial velocity is 0, so this one no more. So we have half at square and half at minus 5 square, because this person jumped 5 seconds later. Okay, so any problem with the distance traveled by the first person and the second person? Any problem with this? I just try to find out the distance traveled by the first person and the distance traveled by the second person. Is there any problem with this distance?
Problem, sir.
No. Then I want to know what is the difference in the distance. So I use the distance traveled by the first person minus the distance traveled by the second person, and it's given here, right? SA minus SB. So this first term minus the second term. Okay, then doing some simplification, I finally arrive at the distance between them. The distance between them is 5 over 2 a 2t minus 5. Now there is a factor t here. There's a t factor here. There's a t factor here. That means when the time increases, the value of this thing will also increase. When the time increases, the value of this whole thing will also increase with time. So since it is a function of time, right? Since this difference in distance between them is a function of time, so the distance between them will actually increases with time. The distance between them will increase with time. Okay, the distance between them will increase with time because there is a time factor here. There's a time factor here. Any question or not? No. Now, the second one, I want to know what is the difference in velocity between them? So I use the velocity formula. The velocity formula is like this, right? V naught. It's not U. You use V naught. Okay. So it's V naught. V equals to V naught plus AT. So when you jump up of the helicopter, the initial velocity is 0. So the velocity of the first person is AT, acceleration times time. The second person will jump up 5 seconds, let's say 5 seconds later. Okay, 5 seconds later, you will be AT minus 5. AT minus 5. So this is the velocity for the first person. This is the velocity for the second person. If I want to know the difference in velocity, I will use the VA minus VB. So VA minus VB. The AT and the AT will cancel off. So the final answer is 5A. 5A means the velocity between the difference in velocity is independent of the time. That means the difference in velocity does not depend on the time. It is actually a constant. So since the difference in velocity is not a function of time, the difference in speed is always constant. So that will answer these two questions here. That will answer these two questions here. The first question asks whether the difference in distance, will it get bigger and bigger or not? Yes, the answer is yes, because it depends on the time. So as the time as the time increases, the distance between them will increase. The second question say, is there any difference in the velocity between them? Difference in velocity. And we look at this thing here. The difference in velocity does not depend on time. It is actually fixed. So there is the difference in velocity is always constant. Oh, this thing is just like a mathematical proof